All right, I wanted to show you one more. This time we're going to be minimizing something. So in this case, surface area. So we have a rectangular box with a square base and an open top with a volume. So this time they give us the volume, right, to be constructed. What should the dimension of the box be to minimize the surface area of the box? And what is the minimum surface area? So we have this box, right, and it has a square bottom. So that means that whatever length this is the same length, right? And then so it has some height, right? So square bottom, but the height could be vary and be different from the bottom, or it could be the same, right? So we'll call the sides of the square bottom X, and we'll call Y the height. Okay, or you could use whatever you wanted though. You could use L and H for height. So it's up to you. This is what the book uses, so we'll just stick with those this time. So now let's talk about surface area. So surface area is going to be it's open top, right? So this doesn't count, but all these other sides do count. So so this we're going to add up the area of all 5 sides, right? 1, 2, then we'll have 1 back here, 1 over here, and then the bottom, right? So the bottom is going to be x squared. And then the sides are going to be xy, right? So there'd be 4 of those xy sides. This one, this one, this one, and this one, right? So it'll be plus 4 times xy. All right, so that's our surface area. Now we want to try to get this in terms of one variable. So let's try to use this value that they give us here. So they're telling us the volume is 216, and we know the volume is going to be, in this case, base times, or length times width times height, right? So it'd be x times y. Okay, so this would be x times y, so x squared y, and we know that's going to equal 216. So what we can do is we can solve for y. Yeah, let's do that. It'd be a little easier, right, than solving for x and having to take a square root. So we divide both sides by x squared, so we get y equals 216 x squared, or 216 over x squared, excuse me. Okay, so now I can plug that in here for this y. So I can say s equals x squared plus 4x times 216 over x squared. Right, and so that'll be s equals x squared. This x will cancel out with one of these, so I'll end up with 4 multiplied by 216, which is 864. Oops. So it'll be plus 864 over x, right? Okay, so now we can we want to minimize that, right? Minimize the surface area. So what we can do is we can find the derivative of that. So we say s prime is going to be 2x, and then it'll be minus, right? Because remember, this is 864 x to the negative 1 power. So we'll multiply by negative 1. So it'll be negative 864 over x squared, right? Because we'll take away 1 from negative 1, and that'll give us negative 2, or in other words, x squared in the bottom. All right, so now we want to set this equal to 0 and solve for x. So I'm going to add this to both sides. Okay, and we'll end up with 2x on the right, and then on the left we'll have 864 over x squared. So then we can cross multiply, or really just multiply both sides by x squared, and we get these cancel out, so we get 864 equals 2x cubed. We divide by 2, so we get 432 equals x cubed. Alright, when we take the cube root of both sides, so now we can break down 432, and it's going to be 2 times 216 216 is 6 cubed, so we can just write, well, we can write 3 6s here. All right, and then we get 2 times 3, 2 times 3, 2 times 3. And so we want to look for sets of 3, right? So we had a set of 3. And actually, I could have let me just use these 3 6s, not worry about these. And then we have this 2 left over, right? So that means we're going to get x equals, the 6 comes out because there's 3 of them. And then we get the cube root of 2. So 2 stays inside because it was just a single. All right, so 6 cube root 2. And we're talking about inches, right? So then it says, what is the minimum surface area? Well, first of all, let's see if this is a minimum. So we can take the second derivative. And let's, I forgot to look at our dimensions. We know that x has to be greater than 0, right? And let's see, the most it could be, yeah, I guess we could do the square root of 216 maybe, right? Like we know if y is 1, for example, then the lowest or the highest x could be is the square root of 216, which is yeah, I think a little less than 15-ish, it's 15 point something. Yeah, a little less than 15, 14 point something. Let me see. Yeah, 14.6969, so 14.7 approximately, right? So we know that x is going to have to be between these two values, right? Okay, so so that gives us somewhat of a range, or gives us some endpoints here, right? Let's do s double prime. This is going to be 2 minus, it'll actually be plus, right? Because we'll multiply by negative 2. So 864 times 2 is going to be 1728. And then it'll be over x cubed, right? So if we plug in, if we do s double primed of this value that we just found, I'm actually just going to plug in the cube root of 432. The reason I'm doing that instead of this version is because I'm going to cube it here anyway. So instead of trying to, do all that work, I can just cancel out the cube and just get 432. Cancel out the cube and the cube root. So this will turn into 2 equals 2 plus 728 over the cube root of 432 cubed, right? Which, once again, this cube will cancel out the cube root. So we'll just get 432. So it'll be 2 plus 1728 over 432. We can divide this. And we get 4, so it's just 2 plus 4. And that equals 6. And the key here with the second derivative is this is positive 6, right? Which means that this is a minimum value, right? So this is a minimum value. So it's, and so we know there's going to be some type of minimum. All right, which is good. So that means we want to use it. And so now we can plug that back into our surface area formula here. Okay. We know if we plug in 0, it's going to give us undefined. So so 0 doesn't really help us out. But we can plug in the square root of 216, and we can plug in 6 cube root 2. So let's try both of those. And like I said, one way to do this is on Desmos. So you can plug this formula into Desmos, and then you can just do, like, you can make that f of x equals that, and then you can just put in f of these different values, okay? Or you can plug it into your TI-84, same thing. You can put this in as y equals or y1, and then you can do second trace 1 and put in the values. All right, so I tried, I plugged in s of 6 cube root 2, and that gave us 171.44. I plugged in square root 216. That gave us 274.79. And then since I couldn't plug in 0, I just plugged in something close to 0.1, and I got 8,640.01. And so of those of our critical points here, this is obviously the minimum. And so this is going to be our minimum surface area. So in this case, it'll be in terms of inches squared, right, for surface area. Okay. And then this is our minimum, or actually we want the dimensions, right? So this gives us X. This is our minimum width or side of the base, right? Side of base. And so let's find Y to find the height, right? So we can plug in, so 216, then we're going to plug in 6 cube root 2. We'll square it. And this is going to equal our Y, or the height, right, of our box. And so, so let's plug that into our calculator. 216 over 6 cube root 2 quantity squared. And that gives us approximately 3.78 inches for our height. Okay. All right. Cool. So that gives us all of our dimensions here, and our minimized surface area, right? Let's see. Yeah. So here's the box. Same thing. Let's see the. Yeah. So they got here. They actually calculated that the exact value of that. So. So they did 216 divided by 6 cube root 2 quantity squared at the bottom, and they actually got that exact value there. Cool. All right. So so anyway, we can see here's the minimum, and yeah, we're able to find that by using, once again, our optimization skills. All right. So we'll be practicing this in class. So bring questions that you have with you, and get ready to, kind of formulate these situations, find equations that represent these situations, and then use all of our optimization skills to find the maximum or minimum depending on what the question calls for. All right, and this is something that you can do, like I said, in the real world, whether you're building a garden or you're trying to maximize your profits, right? You can use it in a lot of different ways to help you get the most or sometimes the least out of a certain scenario.